points are just after that point, because what happens first of all is the spacecraft will turn on its transmitter, and the scariest thing as operators that we can possibly have is no contact with our satellite. Because if we've got contact, we can see what's happening, we can learn about what's happening, we can diagnose the problem, we can talk to it, we can send commands, we can try and fix things. But if we have no contact whatsoever, then we don't know what's going on. So that for us is a scenario we train and train and train for. There are many, many reasons why it can happen. There can be small failures, there can be computer glitches. There are worse things, of course, but we hope that none of those have happened. And we have seen it in the past, and we fixed it. But what we'll do is we'll do a sequence of searches using our ground stations, scanning them in spirals, scanning them up and down and side to side to try and pick up the signal of the spacecraft. We'll also try sending it commands we call in the blind. Sending commands in the blind is where we tell it, turn on your transmitter, talk to us. We don't know if it's listening or not, but we try that because its receivers are always powered. So we'll be doing that. If we can get it to talk to us, then of course getting this solar array out is the next most important thing. We charge the batteries just before launch, and then this thing has to survive on the batteries that we've charged before launch all the way until that solar panel is out and turns and points to the sun and starts generating power. So if this doesn't deploy for some reason, we have a lot of backups, we have a lot of procedures, we have a lot of ways of getting this solar array out. Some of them more obvious, just telling it to do it again, using the backup motors. Some of them less obvious, turning the solar panel into the sunlight to try and warm it up and force it free and things like that. But this is a very critical moment, and we will need to work very hard, as urgently as possible, to get the solar array out to reach what we call power positive, which means that the spacecraft is generating its own power. Once we reach that stage, we can take a breath in the control room because things are stable, or at least as stable as they can be. So here we are in the control room, and we will be watching for that power positive state, because that's the point where we know, okay, the spacecraft is stable. The flight director will usually announce at that point we have a mission, because at that point we know that it's not going to die immediately. We will always have the chance to recover something and to work our magic to fix the satellite. But up until that point it can be very difficult. Now what you'll be seeing tonight is you'll be seeing the live feed. You'll also be seeing lots of Twitter updates from our Twitterer tonight, Daniel Lakey. I don't know if he's about somewhere. There he is. Drinking beer, that's responsible. But he will be tweeting to you tonight from ESA Operations. He'll be listening to all of those voice loops. So all of this time we're communicating in that room, we're talking to each other, we're working out what's happening, we're discussing the situation, we're discussing how things are going, and we discuss it using our very special ESOC language that we use to make sure that there are no mistakes. We have a lot of different people. There's some of these handouts down at the front there if someone hasn't got them, but if anyone wants to learn how to speak like you're on the voice loop, this is how we speak. It's designed to make sure that even with people from all over Europe with different accents and things like that, that we always speak clearly and can't be misunderstood, because communication is absolutely key in that room. But Daniel will be listening to all of those and sending out the tweets as he hears them. If something goes wrong, the tweets may go quiet. That doesn't mean that we're hiding something necessarily. It probably means that we're working really, really hard. We might not be on the voice loops because we will all be stood around that whiteboard solving the problem as we have done in the past. So that's why things might go quiet, but you can rest assured that it's not that we've given up, it's just that we're working very, very hard on solving the problem. And, well, ultimately we can look like that when we're solving a problem. I love this photo of Jean-Noël, who is our excellent engineer tonight, who will be looking after the spacecraft's power systems tonight, but he has always that very shocked face whenever telemetry doesn't quite go his way. But ultimately, we usually do solve the problems, and we will have problems tonight. I don't know of any launch that's gone completely problem-free. They're never usually big, and we do always solve them, but space is very difficult. It's a really challenging environment, and we work very hard, and it's part of the satisfaction of working in that room is solving those problems. Of course, the other satisfaction is 3 a.m. steak, which is something that the canteens open 24 hours when we're doing launch and early operations, and yeah, when you're on shift, because we're in that room 12 hours at a time. So the team tonight will be in that room from 2 a.m. to 2 p.m. Another shift will take over 2 p.m. to 2 a.m. and the other team are back on again. So it's a pretty punishing schedule. So 3 a.m. steak's not bad. But it helps us work through the problems, and ultimately we end up here, which is the party to put the name on the wall to say that we successfully launched Sentinel-2A. And I desperately hope that we will have and I'm confident that we will have a similar photo taken about a week from now when we put the name of Sentinel-2B on the board. And I hope there'll be anybody in the control room as cool as we are. Or at least we think we were anyway, so that's what counts. So I'm sure you'll all join me in wishing Sentinel-2 the very best of luck tonight.